Good day, my students, my chemistry learners, um, you that you are watching this video. Okay, I want to look at the properties of gas and kinetic theory of gases. Okay, I will try as much as possible to be brief in this short video. So, if this is the first time you are watching my video, I encourage you to like the video, put your comment in the comment option, and also subscribe to my YouTube channel and share my video to other students so that they can begin to have the same knowledge or what you are enjoying now. Okay, what are the properties of a gas? Before I will talk about that, what is a gas? We know that gas consists of molecules separated wide apart in empty space. Okay, and these molecules are free to move about throughout the container where they are confined in. Okay, a gas actually obeys the Brownian motion, or Brownian motion simply explain the movement of gas molecule in an irregular manner, in an haphazard manner. Okay, so but we are looking at the properties, or simply put, the characteristics of a gas. So looking at the properties of gas, you can see one is diffusibility. Okay, gas can diffuse from one region to the other. So, and gas diffuse rapidly throughout, to form an homogeneous mixture. If you have a container where you inject let's say hydrogen gas here, and because the hydrogen gas here is more concentrated there, okay, on its own it will move irregularly to other area, okay, diffusing to other area, okay, from a region where the hydrogen is in higher concentration to a region where you do not have hydrogen in the same container. So we call that process diffusion. So it will diffuse to other areas. So gas has that ability, okay, any gas at all, to diffuse. So we call it diffusibility. And another property or characteristics of a gas is expansivity. Okay, actually gases have, uncountable or limitless expansibility. They expand to actually fill the entire vessel they are placed in. Okay, just like what I explained here. If you have a container, okay, the gas molecule that is present here, let's say A, it will actually move and expand to other areas. Okay, to move to other until you have an homogeneous mixture, until equilibrium is reached. Okay, another property of a gas is that gases exert pressure, okay, on the walls of the container in all direction. If you have a container this way, okay, and a gas, because of its haphazard movement, okay, it moves haphazardly. As it's moving, it will hit the wall of the container like this. This one will hit the wall of the container, this one will hit the wall of the container. Okay, that means pressure will be exerted. Okay, and that happens in all directions, especially when you confine the gas in a particular region of space, okay, particular region of container. So the gas does not just stay in a particular place, point here, but it will what? Exert pressure, okay, by hitting the walls of the container. Okay, another one is compressibility. Okay, that gases are easily compressed by application of pressure, okay, to movable, piston fitted in the container. If you have a container like this with a piston, you can see it like this. Let's say this thing, you can move this thing, you can compress it and relax it. Okay, if you have something like this and you have gas molecule this way, okay, by the time you compress the piston, look at it, the same container. If you compress this thing down, if you compress this piston, I call this piston, if you compress it down, it will now be something like this. Okay, compressing it down will cause pressure exertion. Okay, it will exert pressure, and because it exert pressure, okay, the gas that fill the whole of this place will now be compressed, okay, to this region of space of the container. Meanwhile, it was at the region of this space of the container. So this shows that you can compress pressure, and you can compress a gas. So as you compress a gas, the truth is that you are increasing the pressure. The pressure of the gas will be very high. So the last one is heat. Okay, when you heat a gas, actually, in a confined vessel, the pressure will also increase. When you apply it here now, and this is gas molecule, you see this gas molecule may not be moving very fast, they may just be moving slowly, but because of the effect of heat applied, because of the effect of heat applied, if you increase it like temperature, you increase the temperature of the flame, what happen is that the heat will increase the kinetic energy. Okay, and that already explain the kinetic theory of gas, which I will get into soon. So the heat will increase the motion, the Brownian motion. Okay, it will increase the kinetic energy of this gas molecule, okay, which shows that pressure will also increase. I believe you understand these properties of gas. You don't need to cram it. People cram a lot of things. Just understand. You can see the way I use short diagrams to explain what the properties of a gas is. Now, let us go to the kinetic theory of gases. So kinetic theory of gases. First of all, permit me to say, okay, what do we actually understand by the word kinetic? I have explained what a gas is. Okay, when we talk about kinetic, what do we actually mean, or what do we mean by kinetic theory? Kinetic just is related to movement, related to motion. Okay, so but when we now talk about the kinetic theory of gas, we are simply describing the behavior of the gas, okay, at a particular level. And these gas we are talking about, they are actually ideal gases. Okay, so when we talk about kinetic theory of gases, we mean the ideal gas. Okay, so all the theory, all the assumption of the kinetic theory of gases actually explain the ideal gas. So if you are asked what is an ideal gas, you can actually use the kinetic theory of gases to explain, to define what an ideal gas means. Though I will still come to that, though not in this video, to explain what an ideal gas and what a real gas is. Many students are confused. They don't know how to differentiate this, but it is relevant that you know how to state the kinetic theory of gases without looking at textbook, without cramming it. It's good you know it. So the kinetic theory of gases, number one, that the attraction between the gas molecules, the attraction, the force of attraction, between the gas molecule is actually negligible. Okay, that is the first kinetic theory of gases, that the force of attraction between the gas molecule is negligible. Look at, you have let's say this is our container. Okay, you have a gas molecule here, okay, and you also have a gas molecule here. So the force that is attracting this molecule and this molecule together, okay, what the kinetic theory of gas is saying that the force of attraction bringing this molecule and this molecule there is actually negligible, okay, very very negligible, okay, and that explains the ideal gas, okay. So but another one is that the molecules of gases are in continuous random, motion in a straight line. The molecules of gases are in continuous random motion in a straight line. So this gas molecule, they actually, their motion is continuous, it does not stop, okay. The gas molecule, they are always moving, they are just, and as they are moving, they hit the wall of the container, they will bounce back again, okay. They are always in, continuous random motion in a straight line. Then number three, kinetic theory of gas explain that the molecule of gases collide with one another and the walls of the containing vessel. You have a container like this, that the molecule of gases, look at the gas molecule. This molecule of gas, they collide with one another. As this one is moving, it will collide and hit this one. I hope you understand. As this one is moving, it will collide and hit this one. This is how this one will collide and hit this one. Hit this one. This one will collide, hit this one. This one will, they collide with one another or with each other. Okay, and that with one another and with the walls of the container, because as they collide with each other or with one another rather, okay, they also collide with the walls of the container, and it will come back collide. Not that as the gas molecule hit the wall of the container, it will come out, it will now come out outside. No, no, it will hit the wall of the container and go back. As it's going back, maybe it will hit another gas molecule just like that. So that kind of motion is actually a random, a Brownian, and a regular, and haphazard type of motion. Now, another one is that the collision, okay, we just talk about collision now, okay, that they collide with one another and the walls of the container. So number four, that the collision of gases or the collision of gas molecules, okay, they are perfectly elastic. The collision of gas molecules are perfectly elastic. What do you mean by perfect elasticity in this case? It means that both the kinetic and the momentum, they are actually conserved, okay. Let me also explain it this way, that the gas molecules are perfectly elastic also means, when you talk about elasticity, okay, elasticity, when you draw a rubber, okay, it tries to come back to its original position. Look at this, the gas molecule, these are gas molecule. As they hit the wall of the container, what happen? They will bounce back like an elastic ball. You can see my diagram, they will bounce back. This is the same gas molecule that hit the wall of this container. Now is bouncing back like an elastic ball. It's just that you are playing table tennis. As you hit the table tennis on the wall, what happens with the table tennis? It comes back to you. Okay, that is how these same gas molecules are moving. Okay, yeah, as this one now is moving, okay, it hit the wall of this container, it does not come out from the container, it rebounds back, okay, like an elastic ball, and as it come, it will hit this place to bounce back and hit here, and as it hit here, maybe it will hit this one, it will hit this molecule, and that is what we refer to as well perfect elasticity, okay. Then number five, so the average kinetic energy is proportional to the absolute temperature, okay. These five um assumption explain the kinetic theory of gas. Please, of gases, understand that kinetic theory of gases is actually an assumption or a theory that was described, that describes rather the behavior of ideal gas at a particular level. So I quite believe you understand. And if you do, I believe you do. I believe you do. If you do, then I expect you to share this video to a friend. Do not be stingy. Do not have knowledge of something in chemistry and you keep it to yourself. You share it with somebody, and the person shares with somebody, the person shares with somebody, and that's how it will continue to go, so that the many will have this knowledge. You can see from what I've shared with you, it does not demand cramming. Just understand what kinetic theory is. Kinetic is, then kinetic theory of matter. Okay, this theory was actually assumed by a group of scientists. Okay, and they came up with this. So any gas that obey this kinetic theory of gases is actually an ideal gas. Okay, that means you can say an ideal gas obey perfect elasticity. So an ideal gas is perfectly elastic. But I will come to that later, so that you understand, you can be able to differentiate between an ideal gas from a real gas. So if you understand, please try and share and subscribe to this channel, and also put on your notification button, so that whenever new videos are uploaded by me, you will be duly notified. Thank you. Please, I'm waiting for you to just like, to just subscribe, and to just what now, share. Okay, it does not, the button does not bite, just, you know, just subscribe. Thank you.